Okay, this is part 2 of 2 on our lecture on the research process, which covers chapter 2 from your textbook. Um, I just want to take a moment and back up and sort of focus on what the point of this chapter is and the whole concept of the research toolkit. I'm sure there's going to be some questions about each of these individual areas that we're discussing, but I want you to also appreciate that the intention of this chapter is to give you like the 30,000 foot view of all these different approaches. There will be uh, entire chapters, in some cases one, in some cases multiple chapters covering these ideas as we go forward. So don't worry if you have questions or if you feel like things aren't entirely clear. This is really only intended to give you a basic understanding of where we're going to be heading in future chapters of the book and in the class. Another tool in your research toolkit is the quasi-experimental design. So the term quasi meaning as if in Latin, so like an experiment in a lot of ways, but it lacks certain characteristics. And usually we choose to engage in a quasi-experimental design versus an experimental design out of practicality, out of pragmatics, because essentially we're studying an independent variable that can't be directly manipulated, or we can't randomly assign participants to a level of that variable. So we want to know how the independent variable has an impact on an outcome on a dependent variable, but we can't really assign people either ethically, practically, in reality. So sometimes these independent variables are really things that are pre-existing about the individual, like gender, race, age, ethnicity, socioeconomic status, locale, diagnosis, personality traits, personal history. These are all things that are of great interest in psychological research. But as you can understand pretty quickly, we can't randomly assign someone to race or age or gender. So if we're interested in how those factors, those variables impact an outcome, a dependent variable, we can still study them, but we can't do it in a traditional experimental design. It can be a very powerful design though for looking at generalizability of results. It places high priority on what's called external validity, which is synonymous with generalizability of the research to other settings, place, and people. So when we say something is externally valid, we mean that it's generalizable to a larger group or other settings or different types of situations we might be studying. Um, One thing that is difficult, though, is that confounds can be more problematic, especially for other factors. Since we can't randomly assign, we can't control for those confounds through random assignment. Sometimes what we do is we enter those confounds as a control variable into our analysis, and we use statistical methods to reduce their influence or to eliminate their influence on the outcome. Um, an example from your book, so we've been going, as we go through each of these tools, I want to talk about how Dunn and colleagues, how their research touched on each of these different approaches. So in their larger study of how pro-social spending affected happiness, they utilized a lot of these different types of designs from the kit, and that's why they're the emblematic research from this chapter. So in this case, um, they did a study that extended their pro-social spending hypothesis experiment to a quasi-experimental design, and they wanted to increase external validity. They wanted to see how generalizable some of these findings were. They recruited 16 employees to examine self-reported happiness levels within a business, and they checked their levels before they received a profit-sharing option. And then they also checked their happiness levels after they received a profit-sharing option, and they wanted to see if there was receiving that profit share, that windfall affected them, but they also then wanted to see how people spent the money. But ultimately, this was a quasi-experimental design because they could not randomly assign people to receive or not receive this profit share. They were looking for change over time. And they still find that people were happier based on higher pro-social spending, which they also were able to study, but it was not an experimental design. People were not randomly assigned to receive $5 or $20 like in the previous experiment. They went to a real world setting where the person received a windfall and tried to test the same theory through a different technique, through a quasi-experimental technique. In your book, chapter 11, will go into great detail about quasi-experimental designs, and we'll talk about it at that time. Correlation is another tool in your toolkit for conducting research. It's sometimes called relational research as well. It's a pretty simple design that really allows you to assess how much two variables are associated, two or more variables in some cases. So when we use the term correlation, we're talking about the concept of how things covary or how they are related, but we're also sometimes referring to a specific statistic that we calculate via a specific formula that indicates how closely two things are related. So the idea is to see, as one goes up, does the other systematically go up? As one goes down, does the other systematically go down or up? Things can also have what are called inverse correlations. As one thing increases, the other decreases in a systematic fashion. As pro-social spending goes up, happiness increases is an example of sort of a normal positive correlation. Um, we use these statistical analyses to test simple correlations to how two things are related. Sometimes we're interested in more than two variables, and we can utilize what's called multiple regression, which allows you to have more than two variables involved in a correlation statistic. By definition, correlation is considered non-experimental. The variables are measured, but they're not manipulated. So we're kind of out of the world now of independent and dependent variables. We really just want to know how things are related, and we sometimes may just refer to them as variables, or in some cases, correlates. Correlate is the noun term for two things that are correlated. It provides some advantage because often, again, these are things that practically can't be manipulated. If I want to know how socioeconomic status predicts happiness, for example, I can look at how they're related to one another, but I can't randomly assign people to have a certain amount of money, right? That's not something that's within my control. So it's a way to look at variables that that exist in the real world that tend to be out there and are of interest to psychologists, but that can't be actually manipulated. The ultimate disadvantage, of course, of correlational research is that causality cannot be established. So there's an adage from mathematics, and I'm going to come back to this in great detail in Chapter 7 when we cover correlation, but the basic concept is that correlation does not imply causality. Okay, this is a mathematical term that's been brought into the world of research. Just because things co-vary does not mean that one causes the other. There are multiple other explanations, and correlational research, because it doesn't meet those standards of like a true experiment, for example, it's much harder to make an argument that you can establish causality. But what you can say is that two things do appear to be systematically related, and that can have some meaning in and of itself. Another tool in your toolkit I want to talk about briefly is sampling and survey design. This is a chapter, in chapter 13, we're going to cover this in great detail. Sampling is a concept of how do we go about getting samples from populations, and we'll talk about that in more detail. But really, survey design is the tool in your toolkit here. You've all conducted surveys, right? You've all taken part in surveys at one point or another. These are pretty ubiquitous throughout life, but essentially self-report questions are surveys. And it's a very inexpensive way to collect a lot of data very quickly to formulate hypotheses. So again, it's a non-experimental design of research, but it is a way of just kind of getting lots of data. And you can utilize surveys to then run a statistical analysis to establish things like correlations. It is, of course, limited by the accuracy of reporting. Do people tell the truth on surveys? And we'll talk in great detail about that as we go on in chapter 13. The participant may not have the ability to answer. So for example, if you're interested in personality, people have their own perceptions of what their personality is, but there's a whole other world of definition of personality that the individual may not be able to articulate or really fully represent. Surveys also rely very heavily on representative sampling. If you want to do a survey, if you're interested, in, for example, in what all Americans feel about Medicare for all, okay, that's a controversial issue right now in sort of policy. If you're going to go out and conduct a survey of quote unquote all Americans, from the scientific model, right, that we can't test every single American. It's just not practically possible, right? What we then want to do is we're going to have to draw a sample from the larger population, which we discussed in the last chapter, and we're hoping that that sample, that smaller piece of the whole, will represent the whole very effectively. So if you want to conduct survey research, you have to make sure that you're doing an excellent job of sampling because you want that sample to be representative. Another subtype that we can think about in the sampling method is what are called performance-based measures. You've all taken, college board exams like the SAT and the ACT to get into college. If you're interested in going to grad school, you'll take additional tests like the GRE, the LSAT, the MCAT, all these things. These are survey designs of other forms, but these are also kind of captured in Chapter 13. We talk about performance-based measures. There's a whole school in here called psychometrics, and psychometrics is really comparing collected sample measures against a normative standardized measure from a larger sample. So The idea being that we go out and we get a really huge sample that we call normative, right? By virtue of its size, it's considered to be very representative, and by our sampling method. And then we want to give that test to an individual and then compare them to the larger sample. So psychometrics can often involve assessment measures, things like intelligence and performance. The Wechsler Adult Intelligence Scale, the fourth edition, the WAIS-4, excuse me, is one of the gold standards for intelligence testing, IQ testing. I'm sure you've all heard of IQ testing. That's essentially what the Wechsler is. The advantage of doing this type of psychometric research is that it has repeated validity and reliability measures built in and confirmed when you establish more and more people taking the test, right? The more people that take the test, the more that data can be fed in, and the more you can get what you hope is a better picture of how people actually do function. One big disadvantage that, I believe the field of psychology has really only become fully aware of in previous decades is the problem that some of these psychometric tests, these survey design tests that you can go and administer to people, are culturally biased. There was a lot of controversy in the last couple decades, especially about cultural bias in IQ testing. So it's something we have to consider, and it is a nice little touch on that idea of the humanistic perspective on how we should conduct research. We have to understand ways in which our biases can alter our perceptions of other human beings. The last one I want to talk about today, I'm sorry, last of two, is qualitative research. And qualitative research is not nearly as common in psychology research these days. I think you find that most research in psychology is conducted on a quantitative level. So, things like correlation, experimental, quasi-experimental, they all utilize mathematics. They all utilize sort of quantitative data about variables. Qualitative research is a design for variables that you can't really assign numerical measures to, things that are more abstract. And a lot of times qualitative research kind of crosses that line into values, morals, quote unquote, ought questions. We talked about, how most science is concerned with quote unquote is questions as opposed to ought questions. Qualitative research is, often intending to go beyond the numbers to understand meanings attached to the variable or a particular phenomenon of interest. It often relies on naturalistic observation as opposed to that sort of old logical positivist, tightly controlled lab setting. In some cases, qualitative research involves sort of observation in the wild, so to speak, undetected observance, as long as you are doing so in an ethical way. There are some aspects of qualitative research that are called ethnography. These are controlled, precise, well-defined catalogs that code and classify and analyze observed data collected. Going back to some of the golden era of social sciences research, there was a lot of research done, for example, on the indigenous inhabitants in Papua New Guinea. There's a lot of sociological research that's very famous that are ethnography research, and in that sense, qualitative research about those cultures. So qualitative research kind of aims to understand what, how, when, where of actions and events. It's trying to get into the actual environments that we're studying. It often yields data that regards meaning, metaphors, symbols, and so on. We're going to cover this again in great detail in chapter 14, but if you go back to the dichotomy we presented early in the chapter about deductive versus inductive, qualitative research is best suited to inductive research, which is, you're really trying to look at data that you're gathering in this fashion and inform the theory and modify the theory based on those observations to flesh out the theory in some ways. I'll give you a quick example of qualitative research from the field. There's an example of Hussein and Griffiths in 2009 from your book. They were interested in the attitudes, experiences, and feelings of online gamers. And so, of course, people have a lot of questions about the relatively new phenomenon of online gaming. It hasn't been around for that long, and we don't necessarily know what the psychological implications are, good or bad, for online gaming. So these researchers recruited and interviewed 71 online gamers via methods that were online themselves. So like they sort of solicited people online. And they allowed gamers to sort of create their own narratives of their attitudes and experiences with so-called massively multiplayer online role-playing games. The largest example would have been like World of Warcraft, was very, very popular for a long time. And they examined that collected data. They didn't assign numerical values to anything, but they looked for themes and trends and things that were repeated consistently throughout those narratives that people produced. And they posited questions related to the online psychological impact and people's potential addiction, for example, to these types of online worlds. So that's a good example of the type of qualitative research you might see in the field of psychology. Another tool in your toolkit, not necessarily a type of research per se, it's incorporated into virtually all research approaches though. It can be a standalone type of research in its own too, is literature review of various forms. Now we're going to cover literature review in the next chapter, in chapter 3, so we'll be coming back to this in a lot of detail. But it is a tool that we use to sort of get the lay of the land in the existing body of knowledge, right? We want to know what the state of the current knowledge base is about this subject that we're interested in. We want to know how strong that past research is, how consistently or inconsistently it's looked at things and found results. We want to look for important issues or gaps in the research knowledge. That's often a great place to develop your own research studies, is when you do a literature review, you say, yeah, but they didn't ever look at this phenomenon, or they've studied X and they've studied Y, but they've never really looked at how X and Y are interrelated in a way that's meaningful. So through this tool of literature review, which is again integrated into most types of research, there's some type of literature review, you can sometimes find places that need to be filled in the body of knowledge. And so it can direct future research as well. Literature review, of course, is incorporated into journal articles of all different strategies and approaches to research. You know, qualitative research articles, experimental, quasi-experimental correlation. They're all going to have a little bit of a literature review built into them. That's part of the process of writing a scholarly article, is to show what's come before, what's been done in this field, and to sort of explain how you arrived at your particular research question and design. But what you're starting to do is evaluating the body of knowledge by synthesizing all these empirical findings that you can find in the literature across independent studies, right? And this is starting to touch on something really important in the underlying strata of how we do research and how we do science. You know, it is this idea of it's done in the public. It's done in a way where you publish not only your results and your interpretations, but your method, and in some cases you publish your hard data if people can request it. And so that allows other researchers and yourself, you know, going forward, to look at that information that you've produced, for them to look at all the things in the body of knowledge on that area and try to draw some conclusions, to try to synthesize what is the aggregate of all of the things that have been found, and how will that help me to design and direct future independent study. As I mentioned, it's often used as the background and the support and the justification for a proposed research study. At the beginning of virtually every psychological journal article, you're going to find a literature review. There are also some standalone literature reviews called meta-analyses that we're going to talk about in Chapter 3. So now we have this research toolbox, right? We have these different strategies and approaches for conducting research. It's presented in a way that we can pick and choose what we need to investigate a topic. And the example of research in the chapter, the done, you know, body of research they've done on pro-social spending and happiness, shows that, you know, you often utilize multiple tools in the toolkit over the course of multiple studies. But this toolbox allows for decisions on methods of data collection, design, models, analysis, statistical methods, results, ways of reporting your results. It's all sort of built in with the approach that you decide to use. And the aim, as I mentioned, is to use multiple methods and outcomes for optimal strength, to find converging evidence that supports the hypothesis and the theory under investigation. That's that replication that we want to see, that gives us more trust in our findings, that we have a better handle on what's really going on in the relationship between these variables. At the key, a key aspect of that, at the core of it, is the idea of scientific skepticism. And we've talked about this going back to the first lecture, right? That this is an important part of how we conduct science. We start with a mindset, like Descartes, that doubts, questions, and withholds judgment until the evidence can establish the knowledge of the theory investigated. We assume that the proposed theory or hypothesis is wrong. Okay, we start from a place of saying we're going to investigate this in a way where we're trying to prove it wrong to a certain extent. And this is really deeply rooted in the concept of logical positivism and empiricism. There's no established standard to compare one study to another, but we're really trying to rely on this accumulation, this aggregation of knowledge from all the different data that's been collected and analyzed and then published in various journals and various forms. Another key way we evaluate research is through peer review. This plays an important role in how psychology and science as a whole builds upon the knowledge base. You might think about this peer review as the quality control system that evaluates the reliability and the validity of research findings. So, um, some people call this refereeing, right? But essentially, this is how science is conducted. We submit a written report of data, findings, conclusions for publication to a journal. We're saying we want to disseminate this knowledge on this study topic. And then before it's ever published, a group of peers who are assigned to have some degree of expert in that area, and they analyze the report for the quality and the scientific soundness, and they will then give their opinion about whether or not it should be published in the article. And then once it's out there, of course, then other people will come along and read that article and evaluate it in a similar fashion in terms of, am I going to rely on this in my own literature reviews? Am I going to allow this to guide my own research? Is this going to inform how I understand the phenomenon in some way? Or do I disagree with it because I see flaws in it? And these reviews before it's even published, the reviews that are done by the experts are rater analyzed. They're determined if they want to determine if the scientific integrity was retained and if the knowledge is trustworthy. And once it's out there, we're going to continue that process of evaluating it. There's something called the impact factor metric, which is related to studies that are peer-reviewed journals out there. It basically talks about, a simple metric for the impact factor is how many other journal articles then cite that article, sometimes over a 2-year period in a limited window. But if you think about the whole process of building on the body of knowledge, if your journal article is important, if it's well designed, if it's very rigorous in its scientific approach, if there's something about it that's very meaningful in what you found in terms of your relationship between variables, then one would assume that researchers that come after you are then going to use that as an example in their own literature review and cite your journal article as supporting their understanding of the theory or of the thing being studied. So the idea is, it's almost like, I don't want to even compare it to this, but it gives a sense of like your clout. Like in social media, people talk about the number of followers someone has, for example. But basically, what's going on is how many other people out there in your world who are also doing peer-reviewed research are citing your study as being meaningful to them or as useful in formulating their own design or their own findings about an area. And a higher impact factor is interpreted as a higher indicator of the quality of that research. So both impact factor and peer review are sort of global benchmarks for the quality of a research study. And this whole process of evaluating and critiquing research, it raises questions about how do we do this? What metrics do we use? And the ones we really try to focus on are reliability, validity, generalizability, right? How much does it generalize to larger groups of people, different types of people, settings, populations? And finally, is it relatively free of bias? By looking at it, can you see that it was the person who designed and conducted the research did their best to eliminate as much bias as possible? On the previous slide, I touched on a few of the metrics that we use to evaluate research. Things like reliability, validity, generalizability, biases. I want to touch on a few of those in some detail on this slide. So I've mentioned before that the concepts of reliability and validity are going to come back over and over again throughout the course. One form of reliability we can be interested in when we're critiquing research is the reliability of the measurements. The measurements that the person is using in the study, for example, the way they're measuring the outcome, the dependent variable, is it consistent, reliable, in that sense? Remember, reliability is synonymous with consistency, and of course, is it valid, right? When you use it in various groups, settings, and conditions, is that measurement still reliable and valid? So as I said, validity and generalizability are important. Research questions and outcomes to be of value need to be valid and to some degree generalizable. So why would they need to be valid? Well, because we want to make sure that we are studying the thing that we say we are studying. If a result, a question or an outcome, whatever, is invalid, it means that it is targeting something other than the construct that we're claiming we're studying. one of the ways we can sort of assess validity and generalizability, more importantly, is how results converge across methods and designs, that replication process that's so core to scientific research. Peer-reviewed validity is criticized sometimes for being more favorable to internal validity over external validity, meaning that peer-reviewed researchers might be too focused on making sure that the person is designing a rigorous, elegant, good study that can attribute causality, as opposed to, is it externally valid? Does this mean a lot in the real world, right? Can we take it and apply it to the larger population or to additional populations or settings? This is sometimes referred to as the selective enforcement of scientific principles in journal publication. Um, what it's getting at is the fact that sometimes researchers and academics can perhaps become too ensconced in the ivory tower, so to speak, right? And they're focused so much on, is this a well-designed study, as opposed to, what does it really mean in the grand scheme of things? How much is it really telling us anything about this phenomenon? How much can we generalize it to other people and out there in the real world? One way that we can evaluate and critique research as well is multicultural analysis. This is where we try to focus on and examine and understand the similarities and differences across culture. So, as I'm sure you're aware, there's certainly a sort of Western European bias in a lot of the dominant research in psychology, and that's changing very rapidly. But a lot of the early researchers were, from Western democracies, places like the United States and England and Europe, and so we have to stop for a moment and understand that this research is all conducted within a context, right? That it happens within a cultural context. And we need to acknowledge that humans, for example, can't be randomly assigned to cultures. You can't, and I don't just mean nationalities or ethnicities. We're saying that we are, when we're studying a particular culture, even if it's related to a variable, a culture related to that variable, it doesn't involve random assignment. And so we are trying to delve into a specific world. So, for example, people that are blind, people that have PTSD, or have been through trauma, we can't randomly assign to those things. And those are cultures within themselves that need to be given their due respect and examined within context. There are two key important principles of reliable and valid research that multicultural examination helps with. We always talk about how we want a well-described sample that can be stratified, that you can really arrange on a characteristic. And you have to understand the cultural context to do that. We want to look for something called measurement invariance, right? We want our measurements to be measuring the same construct across groups. And one way you do that is you look at how that measurement is valid within different cultures. If it's consistently measuring the same thing in different cultures, then we say that measurement has good invariance, and it's a good statistical property you want to see. It's essentially saying that, I can probably generalize these results because this measurement measures the same construct even when it's applied to a different culture. Okay, well, that will do it for our lecture on Chapter 2 from your book. I will see you here for the Zoom meeting this afternoon.